Welcome. Good morning, everyone. Welcome to this section on the impact of farming on people and the planet. My name's Karl Schneider. I'm the editor of Farmers Weekly, and I'll be chairing this session. And this morning, we're going to tackle some of the really big questions about modern farming. And in the process, hopefully, take on some of the myths and misconceptions about that we often hear on this subject. For me, the key question is, can we feed the world's growing population without breaking the planet? And to help us, I'm joined by a panel of experts who are all working in areas that have a very direct bearing on this question. So I'll just introduce them very quickly, one by one. If you could wave your hand as I introduced you. So firstly, Drummond is Chief Executive of Lynch, which stands for Linking Environment and Farming. This is an organisation that's been working with farmers since 1991 to combine productive farming with good environmental stewardship. Dr. John Lynch, that's it. John is a postdoctoral researcher at Oxford University. He's working on improving our understanding of the impact of livestock farming on climate change. So we're going to hear a bit more about that in a moment. Professor Michael Lee, hi Michael, is Deputy Vice-Chancellor at Harper University as of a few weeks, I understand. Michael, your new appointment there, you were previously at Rothamsted. Harper has a global reputation for its agricultural research, and Michael is an expert on sustainable livestock systems. Dr. Andrew Neal, hi Andrew, is a senior researcher at Rothamsted Research, which is the world's oldest agricultural research centre, and again has a global reputation, and is working to improve our understanding of soils and what makes them productive. And last but not least, glad you could join us, Catherine. Catherine Pratt is Chief Operating Officer at the Small Robot Company. That's a really exciting company that's developing robots that could dramatically change the way we grow crops. So stick around to hear about that shortly. This is going to be a very informal panel discussion. So we're not going to have PowerPoint presentations. We're not going to have people talking at you for sort of minutes on end. We're going to have a conversation around these subjects. And Caroline, can I turn to you first? As I said in my introduction, Leaf's pioneered this concept of sustainable farming for almost 30 years now. What have you learned over those years? And is it really possible to combine highly productive farming with care for the environment?
Thank you, Karl. Well, the answer, of course, is yes, and it needs to happen like that. So really what we've been looking at is a sort of an integrated farming approach. So every single day, a farmer will be juggling, 9 or 10 balls at a time, which is about the importance of looking after the soil, the environment, water quality, right through to obviously making decisions around animal husbandry and crop health. And for us, that drive has been so critical to really engage the environment, nature-based solutions, and improve and enhance biodiversity alongside that. I think we sort of, there's a wonderful little saying, forget nature, it'll go away. And she will, and she is. And from that perspective, it is so important that we understand better about the skills of working with nature. Nature is all around us, whether it's in the soil and the really active, alive soil biodiversity that we have, or, of course, in our water and around our habitats, the insects, the populations of birds and things like that. And getting that balance right is very key. So we've learned a lot. I've been really lucky. I've been with the organisation, running the organisation since it started. And technology has changed so much. Back then we just started to introduce computers, the internet, emails. Maybe they'll survive, maybe they won't. They have. And we had a lot of our tools were paper-based, carbon copy documents. Fast forward now, our capability to collect data that is both useful and also provides evidence has been so key. So what an exciting journey, what a lot of change is happening. And I think that continuous improvement is a key part of all of this.
So how is how have things changed over those last 30 years? What can we do now in terms of farming more sustainably that maybe we couldn't do, or was a lot harder 30 years ago?
So I think we were perhaps just at the sort of the throes. We'd come through the 80s and the 70s, where we'd introduced a lot of chemistry as an industry to actually cure and try and sort of defend farming and our production against insects and bugs and things like that. And that had bad consequences. And from that, we have learned a huge amount, and the amount of change in terms of getting the balance right around cultural and physical means. So we've moved away from the plough in most cases and introduced things like minimum tillage to avoid the disturbance in our soils, to really capture carbon and to keep the soil alive and get our wonderful little friends, the worms, working really hard on our behalf. We've moved to more biological methods in terms of helping support fungicide controls by introducing things like beetle banks and field margins, where we have insects and other natural cultural defense mechanisms being introduced. And that's also being driven into where, for example, in protective cropping and vertical farming, where we have much more precision control. Because, the great thing for farmers is, they're mixing all the time science, capability and skills, but also a bit of art at the end of the day, because every day is different. You can walk out there, it'll be pouring with rain, it'll be snowing. And so what's also been really important is understanding a lot more around the biology. So that sort of physical, chemical, cultural and biology mix and match has been really important. And science, you talked about Rothamsted, and we're going to hear from Andy and obviously Michael and John and Catherine in a few minutes. And, the science behind really driving solutions that work are absolutely critical. And I think that's where we've also learnt from the science perspective that actually it's all very well doing the science, but it's got to be adapted into the field. And, that's the real skill there. So, gosh, we've moved mountains in that space.
One of the things that really interests me is that some of the things we're doing now, we're sort of learning that our ancestors weren't so stupid. A lot of things that they were doing, but maybe didn't really understand why they worked. We're sort of applying them again, but with a bit more knowledge about what exactly it is that they're doing.
Definitely. And I think that's the great thing about the importance of getting more into intelligence, data. It's that evidence of what can we tweak, what can we understand better, and really go behind it. I mean, when you take vertical farming in particular, and you look at the use of different light spectrums to control pest diseases when we advance a plant, even things like, we'll be looking at poinsettias at Christmas and being able to control the capability of when those flowers come into bloom, that we've got behind a lot more of the nuances with science. I was very lucky. I went a few years ago to Taiwan. And when you look at some of the really wonderful Chinese medicines, Chinese culture, and many of those, as you say, there were those gut feelings. We know it's right, but actually let's get the evidence to not only improve it, but allow us to then adapt it and build the capability for farmers to really drive change as well. And I think we're now at that critical point, because carbon sequestration and our capability to understand around how we can change and what are the priorities as a farmer that we really need to put into practice, and what is it that science on a very prescriptive and also adapted for that precision, our capability now to be precise to the size of a 50p pence in the field is just amazing. And if I think back, in 1998 precision farming was just happening. Now it's mainstream in our farming practices.
I think we're going to hear more about that shortly. You talked about carbon capture, and the whole issue of the impact of farming on climate change has had a lot of coverage in the press. I think if you sort of read the papers, you might be forgiven for thinking that cows are almost single-handedly responsible for climate change. But I understand it now looks like some of the calculations have exaggerated the impact of this. John, this is an area you've been working on. Is it true that the impact of methane from livestock, particularly cows, has been exaggerated on climate change? And if so, why is that?
It's a tricky one to go into the details here, because I wouldn't say it's necessarily been exaggerated or overestimated. It's more that we've been relying on these tools to report and understand the emissions from agriculture that don't really give the full picture. So by far, the main cause of global warming is carbon dioxide emissions from burning fossil fuels. And carbon dioxide, we emit it today, and then a chunk of it is going to stay in the atmosphere essentially forever. So as long as we keep emitting these fuels, we're always going to have more warming, and we're only going to finally stabilize temperature when we cut them out completely. But with methane, which is obviously the big issue for ruminant livestock, so cows and sheep are belching out quite a lot of methane as part of their digestive process. So methane is a strong and important greenhouse gas. Overall, it has the second strongest effect on the climate behind carbon dioxide in terms of where we are in temperature today. But whereas carbon dioxide, we emit it, some of it hangs around warming us basically forever. Methane, we emit it today, has a very strong warming effect for a couple of decades, but then it naturally breaks down. And the issue is that we've been using this metric called the global warming potential to try and compare carbon dioxide and methane. And it converts the relative impact of these gases just to a single number compared to each other. So you have this small per emission long-term effect from carbon dioxide, and you're trying to compare that with this sharp shot that then declines afterwards for methane. And you just can't really fully follow through the dynamics of how they're actually influencing the climate if you try and collapse them both to a single number in that way. So we're trying to suggest alternative ways of thinking about it. And to cut the story short, for agriculture, it means that we do need to bring emissions down. I don't want anyone to think it means we can forget about methane. But it means that for methane, as long as we don't increase emissions, within a few decades, our current methane emissions will basically be replacing old methane emissions as they're naturally broken down. So in terms of net zero and stabilizing the temperature, we need to completely eliminate carbon dioxide. We don't need to completely eliminate methane. We definitely need to get a handle on it and bring it down from where it is today. But there could be a space for sustainable ruminant production, even if they're still going to be emitting methane.
The picture I have in my head, because as you say, it is very complex, but I have quite a simple picture in my head, which is that carbon dioxide, it's a bit like having a bucket and you're pouring water in it, and even if you slow down the rate of sort of putting more water in, the level in the bucket still goes up, and that's sort of the way carbon dioxide just keeps accumulating and contributing to global warming. Whereas methane's a bit like pouring water into a bucket which has a hole in the bottom because it's breaking down, and so if you pour it in at a certain rate, the level goes up till it reaches a point where the flow out equals the flow in, and then it stops. And if you slow down the rate you're pouring it, even though you're still pouring more water in, actually the level in the bucket goes down because it's flowing out the bottom. I know that's a rather simple picture, but is that a good model to sort of hold in your head?
No, I think that's definitely a good analogy. And we try and explain that as saying carbon dioxide is like a stock pollutant, because the warming we're at today depends on the total stock of CO2 we've ever emitted, whereas methane is more like a flow pollutant, because whatever warming we have today depends on the recent ongoing flow of methane emissions. So that hole in the bucket for methane is not very big, and it obviously depends on how much flow we're adding year on year. So we can't just ignore it, but there is definitely a different space for what our final target for these different emissions.
So you're working on finding better ways to account for methane from livestock, better than the current GWP method that you mentioned. Can you just say a little bit about what those better methods might be?
Yeah, so we've proposed an alternative metric called GRP Star, and it's essentially saying if you really want to compare methane to carbon dioxide, then you actually need to take away the impact of the methane from 20 years ago, because that's already naturally being removed. Whereas for carbon dioxide, every new ton you add is just adding and ratcheting up the temperature. So this is how we're trying to conceptualize their impact on global warming. But I'll just emphasize again, this isn't really controversial physics. We've known the climate science for a long time. The issue is that we've been conceptualizing them with a slightly overly simplifying metric. And that's especially stood out when it comes to net zero, because I think that we've sometimes lost the nuance in what net zero means and why it is really CO2 specific, just because carbon dioxide has such a very long-lasting impact on the climate.
I mean, you made the point, which I think is really important, which even if sort of methane from livestock maybe isn't quite as bad as we previously calculated, it's still not something we can ignore. We have to actually do something to reduce that. I think we're going to come on to that in a minute. Another issue is the people in the UK. We often get quoted global figures for the impact of livestock overall on climate change, but obviously the society in the UK is very different from other parts of the world. Agriculture is quite a small proportion of our economy, about 1%. What is the sort of can you give us a feel for how significant the agricultural contribution to the UK's contribution to climate change is?
So if we think of it in terms of the proportion of emissions each year, globally, agriculture is, you get different estimates, but normally kind of between 20 to 30%. But in the UK, it would be more like 10% or even under. And it depends on how you break it down, which kind of food processing emissions you add, and so on. But yeah, I'd urge our viewers to take note if you see these figures reported. Is it global or is it UK? And this is because the UK, we're pretty bad in terms of our climate impact. So our dietary emissions are a fair bit higher than the global average, but our energy use emissions are way higher than the global average. So we're worse in everything, but proportionately, I mean, you can think of it like the whole world is eating something. So the whole world is producing food, having the greenhouse gas emissions associated with that. But fortunately, not the whole world is flying around and using as much energy as we are in the UK. So you do get a different perspective on what scale you're looking at emissions from. Obviously, as I'm sure some of the other speakers will go into, there's a huge difference in the emissions per unit of production as well. So as we hopefully keep improving our agricultural production, keep improving animal health, the emissions per cow or per unit of milk or meat that we get out of it will be quite a bit lower in the UK than a global average, just because agriculture is still developing a lot in other countries. So again, it's just a point to think, well, this global figure, yes, it's recognizing food does have an impact on the climate. We need to be aware of that. We can't think it's only a fossil fuels issue, but is this global average figure, what's that really telling me about the UK production system? And may or may not be as directly relevant.
That's a great lead in to Michael Lee, because I was going to so I guess the key takeaway I get from that is that there may be other things that are a higher priority in the UK in terms of their proportional impact on climate change, but we absolutely can't just sort of forget about agriculture. We've got to do something to reduce the impact. So what are the levers we can pull? Michael, you've been doing work looking at what we can do to change the impact of livestock farming on climate change. So what are those levers that we can adjust, and how much of a change can we make?
Yes, thank you. And John's absolutely right. Anybody who states that the best thing you can do for the planet is to stop eating beef has an alternative motive. There are other things that we need to do and consider. Energy use, transportation, use of fossil fuels, of course. But that's not to say that we don't have an issue associated with greenhouse gases from agriculture. It's about 10% of emissions from the UK, and that methane is an issue. John's right. We do still need to look at methane. But we have been looking at methane, and farmers have been improving for many years. And there's many things that we can do associated with methane emissions, whether it's in terms of intensity, so efficiency of production, and John's already indicated that there are different metrics associated with global warming potential and associating emissions with unit of production. But also we need to consider the wider components of the farm. And Caroline mentioned this perfectly succinctly, as she always does, about the vital role that soil health, grasslands, hedgerows, trees, biodiversity has in terms of the holistic view that agriculture has in terms of balancing carbon. So there's one approach is looking at efficiency, of which we've been phenomenally good at selecting the best animals, improving health, improving diet, improving nutrition, so producing more for less. But another equally important component is to think about the wider environs of the farm: soil health, pastures, hedgerows, trees. So what we call the net primary production, which is about carbon offsetting or taking out carbon from the environment. Because the biggest issue we have with agriculture, of course, as opposed to other sectors, energy sector and transportation sector can decarbonize, and they should. We should move away away from fossil fuels and towards renewables. We need, and that's in terms of energy and in terms of transportation, electric cars. However, for agriculture, strictly, we cannot decarbonize because food is carbon and we are carbon, and we're growing carbon to feed carbon. So if we strip out carbon, what the hell are we going to feed ourselves? So what we need to look at with food, of course, is efficiency and offsetting. So efficiency, increasing the flow of nutrients, including carbon, from soil into food, and of course, then looking at how the wider farming environment captures carbon, because we haven't got 100% efficiency. So it's a very different component, and that's why it's easier to point the finger at agriculture, because strictly we can't 100% decarbonize like energy or transportation.
You made the point very clearly that if we can produce a unit of meat or milk or whatever more efficiently, then that means that the amount of climate change impact we have per bottle of milk or per steak will be lower. So obviously that's a really important thing that we can do to keep on increasing the efficiency of production. I think there are some smart things going on as well in terms of the sort of the genetics of the livestock, what goes on in their stomach. Our understanding of that means that we can maybe find some ways to, even at a given level of efficiency, reduce the impact on climate change from our livestock farming. Is that the case?
Yeah, there's been huge advancements in terms of genetics, breeding animals which are more efficient, of course, and looking at nutritional improvements and rations. And not just in terms of feeding systems, but also grazing systems. So thinking about mixed swards, the importance of clovers and natural nitrogen fixation to ease ourselves away from inorganic fertilizers. We need to do that. We've already got some great fertilizers for our arable systems, and that's animal manures. We need a better utilization of those and less inorganic fertilizer, clearly. And if we think about methane, as an animal scientist, we've been looking at methane for the last 50 years because of loss of gross energy, long before we really truly understood the impact on greenhouse gas. So the farming community have been looking to reduce methane for many, many years because of greater capture of gross energy, as well as the impact on the environment. But it is complex, and the reason why ruminants produce methane is, of course, they are fantastic converters of fibre, utilising resources that monogastric livestock like pigs and poultry cannot use, and grazing lands which cannot be used for other food types. So that's a vital role that ruminants play, a vital contribution for food security. However, the price we pay for that conversion of land and fibre is methane. But as John said, we need to consider methane in the round, think of it as a flow pollutant, do our best to reduce it. And there are ways that we can reduce it through better diets, through better breeding, and some supplements. There's been new supplements looking at reducing methane in ruminant diets, changing that microbial population. But of course, ruminants will always produce a level of methane because they rely on that anaerobic fermentation in the gut, which gives them a unique example, a unique benefit within the food system, which we don't want to lose if we're going to feed a world population.
Okay, so maybe we don't have to stop eating meat because it's bad it's the sort of the main cause of climate change. But what about the argument that it's bad for our health? I know that's another area that you've looked at. That we're told that meat eating gives us heart attacks, clogs our arteries, and so on. What should we stop eating meat? Is that what we should do for our health?
Everything's in moderation. And again, anybody who says actually the best way to deliver a healthy diet is to strip out all livestock products has an alternative motive. Full stop, because that simply is not the case. The WHO says that we should not consume more than 70 grams of red meat per day. Now, the reason, if red meat was bad for your health, like smoking cigarettes, which some people extrapolate and say that they're aligned, the WHO doesn't say don't smoke more than 5 or 10 cigarettes per day. They say don't smoke any cigarettes per day because they're awful for you. Now, the reason why WHO says 70 grams per day is a level that you shouldn't exceed is because a moderate consumption of red meat and animal-based products is good for your health. It is the best supplier of essential amino acids. It is the best supplier of micronutrients, particularly things like iron and zinc, in terms of calcium for dairy products, which we need for healthy diets. And we, as a population, and particularly in the US, we are deficient of certain micronutrients, which we can get more bioavailable from livestock. Now, that's not to say you can't be a healthy vegan or flexitarian. Of course you can. But you need to consider replacing those micronutrients that you would get naturally from animal-based products. And of course, and it goes back to moderation, and this is why the WHO is exactly right. And if you speak to any health or health scientist who knows about nutrition, and that's why animal-based products are part of an Eat Well plate and guide, is it's not just the component of the meat or the milk or the animal-based products. It's how it influences the absorption of the plant-based foods on the diet. The most healthy diet is a mixed diet, and that benefits the nutrients within the plants, which should be the vast amount of our diet. The biggest majority of our diet should be plant-based. We need more fruit and vegetables for fiber, absolutely water-soluble vitamins and lots of minerals from fantastic plant-based components. But it's actually the small component of the animal-based diet which improves the bioavailability and absorption of other nutrients coming from the plants. And especially if you think about protein. Protein is complex. There's a lot of amino acids, essential amino acids. And if you get all your essential amino acids, the ones which are most likely to be limited, which you're more likely to get from animal-based proteins than plant-based proteins, if you get all those essential amino acids, it will increase the use and utilization of the plant-based amino acids. So that's in the round. So the most sustainable diet will be one that contains both plants and animals, but more plants than animals. And that's where we get it wrong.
I want to pick up on something that you said earlier and bring Andy Neal in here, because you talked about sort of looking at the bigger picture and the role of livestock in making the whole of agriculture, including crop production, more sustainable. And a key thing there is the impact of livestock on the soil. And Andy, this is your area of expertise. I want to kick off with one thing. I've heard it mentioned in the press that we only have 100 harvests left in our soils, that our soils we've depleted them, and they're going to run out of goodness so that we can't grow our crops anymore. Do you want to just kick off? What is that true? And what's our understanding of what we mean now by, I know you don't like the term healthy soils, but maybe productive soils?
Well, that comment about only having 100 harvests left has sort of proceeded before me wherever I seem to go. And so I know the person that made that comment, and I think the circumstances were that he was discussing something that probably a lot of people have seen when they drive through agricultural areas. There's a lot of soil running out the farm gate. And what we know is that carbon in soil is very important for maintaining the structure of soil. And what we're seeing when soil runs out the farm gate is a lack of carbon effectively acting as a glue to hold soil together. And that's why when it rains, it just heads straight for the gate and it runs down the road. So John Crawford, I'm going to name him because he deserves to be named. And I think the discussion that he was having was the effect of all this soil loss could have very dire consequences within a relatively short time frame because of the loss of valuable fertile topsoil running out of the gate. And really the point there is that we need carbon in our soils to maintain it as a healthy, I'll use that word, although I don't like it necessarily associated with soil, but it's an integral part of soil and also allows us to maintain it where it should be in the field and stop it running off down the street. And I think that's where that comment came from. There are lots of other issues to do with soil, but that comment was specifically about the loss of topsoil when it rains. Do you want me to say more?
Sorry, there's a slight delay on between the image I'm seeing and your voice, so I wasn't sure if you'd finished or not. You've done a lot of work looking at the thinking about soil as almost like an entity, like a living thing in its own right, rather than looking at the individual elements. Can you tell me a bit about that and how that sort of changes our understanding of sort of what's going on in the soil, or what we need to do to keep it working for us?
I think this is one of the main misapprehensions that humans have about soil, is we tend to walk past it or over it and think of it as a thing. And of course, things can be left alone and for long periods of time, and you come back to them and they're still the same thing. But actually, soil is a product of biological activity. Now, it's not, if you put carbon into soil as a stick, for instance, it doesn't just stay a stick. It gets degraded and broken down, and that carbon becomes an integral part of the soil. And the carbon is the fuel and the lifeblood of soil. So just thinking about it as a thing misses that whole philosophical issue to do with how we maintain soil as a viable living entity. We really need to think about soil as a product of biological activity. And the way we're thinking of it is we're really harking back to Richard Dawkins' extended composite phenotype and seeing soil as a product of the genes that are existing within it. And really, it's about this continuous flow of energy and carbon through the system that maintains it as a functional, efficient system. And I think I don't like the term health, but what I do like is the term efficiency within soil. And I think that comes back to a lot of what of us are saying here, that it's that efficiency that's really important. And if you look at natural environments, one thing they're very good at is the efficient turnover of nutrients. And really, if science can help farmers do anything, it's to understand how to be most efficient in using the nutrients they have to generate as much food as possible. And an efficient system is unlikely to be one that is degraded, right? So actually going back to efficient practices like getting carbon into soil is to the benefit of farmers. It's not to the detriment of them. And I think getting that inside our heads would be a really good thing for the whole of society.
So again, maybe this is another case where our predecessors, farmers who farmed a century or two ago, maybe understood something that we're relearning, the importance of combining livestock and crop production together, and that the carbon from the livestock is an essential part in keeping the crop production effective and sustainable. I was going to ask you a bit more about soil. Sorry, go on.
Yeah, well, I would say...
Okay.
Well, I was just going to say, you're right. And the two main sort of revolutions in agriculture, really, the first one in the 19th century with the invention of inorganic fertilizers, and the pressing issue there was to feed an ever-increasing population. And then in the 70s, that happened again with the Green Revolution. Again, there was this issue about feeding populations. Each of those revolutions has taken us away from thinking about the soil particularly, and thinking that we just need to feed the plant. And that probably for very good reasons at the time, but now with hindsight, we can see that there were issues with those revolutions. So yes, it's those steps of taking us further and further away from this nice, tight, coupled, efficient system that existed before inorganic fertilizers came to be used so widely.
Again, that's a nice lead in to bring Catherine in here. Thank Catherine, you've been very patient. Thank you for sitting there patiently. Catherine, you work for the Small Robot Company, and I've had the pleasure of seeing some of your sort of robots in action. Very exciting. Can you just start by telling us a bit about, you've got Tom, Dick and Harry, haven't you? What are they and what do they do? These are on-farm robots.
Yep, we've got Tom, Dick and Harry, and we've also got Wilma as well. So Wilma's out there looking after the boys. She's sort of the bossy one and the brain of the system, if you like. Tom is our monitoring robot. So Tom goes out into the field. At the moment, we're focusing on wheat in the UK, but theoretically, we can expand that to be any arable crop anywhere on the globe. We've building the robot unit that can go out, capture all sorts of different data using all sorts of different sensors. We're focusing at the moment on things like identifying wheat within an image and identifying what are called bad weeds within that same image as well. So we're doing weed categorization, we're determining which plants are growing where in the field, and we're giving each of the plants a very specific location so that we know we can build up a map of what is where in a farmer's field, and then we know exactly what is where, so we can then start thinking about what we need to do in order to treat or help grow whatever plant is in a particular place. We take the information from Tom and we make that available to the farmer in Wilma. So Wilma is the user interface or the application that the farmer can access and see the map of their field. But she's also more than that. She's got an AI back end. So she's processing the data and using sort of agronomy knowledge, if you like, to make decisions about the plants in the field and can propose then next steps and next actions to take. She then pulls together a map for Dick, and Dick is our sort of caring robot, if you like. At the moment, we're focusing on Dick being our weeding robot. So Dick goes out and follows a route that's been generated by Wilma using the data from Tom. And Dick goes out into the field and targets individual weeds that he wants to remove. The beauty of this is that we can leave some weeds in place. So building on from what Andy was saying about the carbon in the soil, if there's particular plants that are actually beneficial to stay there, or particular weeds that are beneficial to stay there, we can leave them and leave them grow and leave them support the biodiversity, leave them support the growth of the actual wheat plant, rather than sort of applying a chemical spray across the whole field, which will kill off everything. So we can be much more targeted with our approach.
That seems to be the essence or the beauty of this approach, that by treating each plant individually rather than what has previously happened, you sort of treat at best a section of a field or maybe a whole field as one thing, that you can much more precisely take actions and significantly reduce the amount of inputs you need, for example, or maybe even eliminate them if you're going to use laser weeding or something like that.
Yeah, we're actually looking at electric weeding, so targeting with an electric probe where we put a current through the weed, which effectively boils it off right down to the root base. So by doing that, we're almost certain that we have killed the weed we're targeting. We can send Tom back to go and have a look. So if it's not been successful, we can go and have a second attempt. But it does mean that we then need, or the farmer will need to use less chemical to actually tackle a weed problem within their field. The drive that we've got is actually to remove the chemical in that particular instance and get the electrical weeding capability so efficient that the use of chemicals in that instance isn't needed. The other robot then that we've got is Harry. And Harry is our planting robot. And again, Harry allows us to be precise. So we can plant a seed, any type of seed we want at a particular location. So again, that allows us to almost 3D print the field. So if we wanted to specifically put in a different plant next to a wheat plant, maybe it's one that's a pollinator plant that bees love or something like that, we can then drill that seed in. So it allows us, or it will allow us over time, as we're collecting more and more information with the Tom robot, we'll be able to analyze all the data trends because we'll have vast amounts of data coming in because we're looking at things right down to sort of centimeter level rather than, a drone or satellite level where they're looking at meters. And we can use all that data. We can use the data across all the farms. We can look for more trends. We can work with agronomists to help us determine what the next best action is for our robots to then take. And our Harry robot can either go out and sow seed in a completely different manner to what we currently do, which is going to be far more effective and efficient for sort of the soil soil health. Sorry, Andy, to use that word, but the soil health. And then the Dick robot, as you say, can target to kill off only particular weeds. The other thing that we've got is, because our robots are lightweight compared with sort of modern day tractors, what we're not doing is compressing the soil. So we're removing the need to plough. The robots themselves aren't going to cause compaction in the same way that the big heavy tractors do. So by removing that need to plough, we're actually, again, trying to keep the soil in the field rather than encouraging it to migrate away. And the final thing, I think, from a sort of an environmental benefit or side of using the robot tech, is that we've removed the use of diesel. So we're looking at battery-powered robots, so there's no diesel consumption then. And with the solution that we're looking at, we're actually looking to go a bit bigger than that. So we're looking to actually use things like diesel vans to get electric vans to get the robots into field. So we're trying to cut sort of the diesel out right the way across the solution. So not just in the actual tech solution in the field as well. We're looking at it from a company-wide view.
I think the picture I've heard described once is that in future you might see these little robots sort of running across the field, and when they feel their battery's running out, they scurry back to the edge of the field to their solar powered charging point, plug themselves in, recharge, and then off they go again. I mean, it's a very scientific.
Yeah, we like to call that the kennel. We sort of like, a dog would run back to its kennel to sort of recharge its batteries and then go back out and carry on resuming work.
So I mean, I'm a physicist by background, and I'm really interested in this technology. So this is very exciting for me, because it says not just that there's good things happening on the ground today in farming, but if you look ahead, some of this technology could dramatically improve the sustainability and give much more control over our impact on the environment. How long are we going to have to wait for this? How long before, when I drive through the countryside, I look over the hedge, I see sort of robots scurrying around?
Well, you could actually go out today, not literally today, but maybe on Monday. We've got a few robots out in the field, actually working and sort of monitoring the crop at the moment. We're building our Dick and Harry robots. So we're talking years rather than decades. It's imminent.
Thank you very much. We're doing okay on time. We're a bit short on time for questions, but I do want to sort of address some of the questions. There's been a brilliant discussion going on in the side panel that I've been sort of keeping half an eye on during our discussion. There's far too many sort of things to take on individually. One of the themes that I've picked out, several people have sort of raised this, is that, okay, maybe sort of livestock farming isn't as bad for climate change as we may have thought, and maybe it's not going to destroy our health, but it's a very inefficient way of using land. And to produce the same amount of food using livestock farming, you need a lot more land than to produce crops. And so maybe for that, there's that argument against livestock farming. Does someone want to pick that up? That maybe we can use that land better than for livestock. Michael, you put your hand up.
Yeah, if I start on that, and that goes back to my comment about the vital role that ruminant livestock have in food systems and sustainable diet. Because I agree, the best land, and I put a comment in the check, we need to look at what we grow and how we grow it. And the best land should be going for crops to feed humans. There is no doubt, if we have a world growing population, we want to protect biodiversity, therefore we don't expand our agricultural land. The only way that we're going to round that circle with more people on the planet who will need more food is to more efficiently use the agricultural land we've got. So that will mean the best land going to grow crops to feed humans. However, as I've already mentioned, the vital role that livestock can play in delivering healthy, balanced diets to everyone, we need to find the position that livestock will hold, the niche that livestock will hold, which will allow the best land to go into crops to feed humans. And that is the vital role, again, that ruminants will play in utilizing land which is not suitable for growing crops, either because of topography, soil type, meteorological conditions, a whole array of factors of why grasslands are grasslands. And also, we need more of a circular economy. And this will support the monogastric industry, pigs and poultry, as well as ruminant systems. And that's thinking about waste streams and food waste of going into those systems to feed those livestock. And there's been many analysis done about land use efficiency with or without livestock. And every single analysis has showed that if you strip out all livestock from all agricultural production systems, you would need more land, not less, to feed the population. And that is because you strip out the potential production of food from land which cannot be harvested, and you lose the circular economy in terms of recycling of nutrients back into food systems, which is where livestock need to be concentrated. So that's the really exciting component that livestock can deliver in food systems, which is often forgotten. On top of that, and we need to do more of it, and we mentioned this already, the vital role that livestock will have in delivering soil health and mixed farming systems, thinking about rotations, using livestock to improve soil health. The most degraded soils in agricultural lands are arable, because you haven't had that continual return of nutrients into those systems. The potential is the brown gold that all livestock farmers have on their boots. Let's get some of that back into the soils, linking arable and livestock systems. That's the critical role. A view that removing livestock will deliver sustainability is crazy. And those people have alternative motives, either using global averages or just to get some high impact paper because those journals seem to like those sort of texts, those sensational stories. But it's not grounded in reality or fact.
We're pretty much on the end of our time now, but maybe has anyone got any final comments they want to make either on that or on anything else that's come up?
Yeah, I might just follow up on what Michael was saying there. And I think that there's a consensus forming around now, kind of the idea of less but better livestock. So if the whole world is trying to catch up and eat American levels of meat, then it's a disaster. The only way we're going to do that is mass conversion of
I think we might have lost you for a moment, John.
I think we've lost John. But I'd have put a comment in the text, which is I think John and I have been bouncing some questions around, which is about the level of and that's got better.
They're only going to provide some.
John, I'm afraid we can't hear you properly. You're only coming through intermittently. So I know you've been. Let's add comments in the chat. I'm sure we can carry on the discussion there. We are over the end of our time now, so I'm going to have to draw this to a close. Thank you to all of the people who've been listening. For me, the takeaway is, whilst no one is complacent, I think maybe the farming isn't as bad for the planet and people as maybe some people might have been forgiven for thinking, reading sort of the press and the papers. But for me, the most exciting thing is looking forward. There are good reasons to be optimistic about the great work that's going on the ground amongst farmers and researchers that are doing some really exciting things to make the way we produce food much more sustainable in future and tackle some of these problems. So it gives me a bit of confidence anyway that we can feed the world without sort of destroying the planet. So thanks to everyone who listened, and a huge thank you to all of our panelists for joining us today. And keep the discussion going in the chat, and lots more sessions to come. So hopefully see you in one of